Okay, so the past 2 days, on Monday when we talked about the worksheet determining congruence, and yesterday we talked about how you could rotate, we did it on the computer, or reflect, or translate. We've discussed congruence, and we used that phrase, same shape, same size. Same shape, same size. It might be pointed a different direction, it might be on a different part of the graph, but it was the same shape and same size. We used translation, reflection, and rotation to prove congruence. Okay? Because when you translate or slide it, when you reflect it or flip it, when you rotate it or spin it, twist it, it always ends up the same shape and same size. But today we're going to talk about dilation. And remember, dilation is used when two figures are similar. They are similar. Remember, the major part of dilation was the use of a scale factor. So with dilations, we're going to change the size. So we're going to have the same shape still, but it's going to either get larger or it's going to get smaller. Okay? We're either going to enlarge it or reduce it. So just like yesterday, they're going to give us some figures on a grid, and they're going to ask, determine if the two triangles are similar. First thing to check, are they both triangles with the same shape, but maybe just a different size? Yeah, I agree with that. They're both right triangles. So now what we have to do is we have to determine their side lengths. It did print pretty well on there. Okay? Count the boxes. How tall is it from D to E? 4. Okay. How far across is it from D to F? Say it again. 3. And now on the other triangle, how far from G to H? 8. And how far from G to I? 6. All right, we have to worry about the scale factor. So we have to set these up together. The side length of 4 on that blue triangle would match up with what side on the green triangle? 8. Very good. Then the side length of 3 would match up with 6. Grab your calculator. Divide those two fractions and turn them into a decimal. 4 divided by 8, 0.5. 3 divided by 6, 0.5. What do you notice about these two numbers? They're the same, which means we have the same scale factor. So what we just did is we showed that these are similar. So you would say, yes, they are similar. The sides are proportional. Yes, they are similar. The sides are proportional. And just so you remember, proportional means they have the same scale factor. That 0.5. That 0.5 set that up. Okay? So first we have to check if they're the same shape, even looking the same. Then we're going to check their scale factor. Okay? We're going to repeat this on the next one. Ready? Determine if the rectangles are similar. Everybody take a minute and write down the dimensions of those rectangles. Count the sides, the lengths, and the widths. The lengths and the widths of those two rectangles. Let's start with the one on the bottom left. How tall is it from T to U? 3. How wide is it from U to V? 5, you said? Okay, we go to our other rectangle. How far is it from W to X? 4. And Y to X? What would you say? 7? Okay, now you have to make sure you match these up correctly. 3 matches up with how would I get this blue triangle to match up to this green one? What is that called? Yep, rotate it. We need to rotate this up. So your 3 is going to go with my 4, really. And my 5 is going to go with my 7. Now, grab your calculator, divide those, and see what you get. Three divided by 4, you get 0.75. 5 divided by 7, 0.71. What do you know? They're different. So what does that tell you? Not similar. Very good. Not similar. The scale factors. Yep. Are different. You have to say not similar. The scale factors are different. On the one above, if you would have said the scale factors are the same instead of the word proportional, I would be okay with that too. All right, let's see how much you remember from 6.4 last chapter. Similar figures have the same shape, different size. The size of the two are related from the scale factor. When your scale factor is between 0 and 1, the dilated figure was, did it get bigger, smaller, or stay the same? It got smaller. If your scale factor is equal to 1, did it get bigger, smaller, or stay the same? Very good. And greater than 1, bigger, smaller, stays the same? Bigger. Okay. If something stays the same shape and same size, what's the word we use? Very good. Congruent. Very good. Okay. I pulled some problems off of Alex on the back. Okay. This first one. Congruent. Same shape, same size. Yes or no? Why not? Different size. Very good. No. Similar means same shape, but a different size. Yes. Okay. How about in the middle? They're congruent? They're the exact same shape and same size? Yes. They are similar then? What scale factor is used? Don't change your answer because you're right. They are similar. What's the scale factor you use when they stay exactly the same? Flip it over. It's on there. You're right. You're looking in the right spot. What scale factor did they use? You're on the right line. When they stay exactly the same, what scale factor is it? Equal to 1. The scale factor is 1. Here's what I'm going to tell you, everybody listening. If you say yes to congruent, you say yes to similar. If the top one is yes, the bottom one is yes. Always, always, always. Okay? Always, always, always. Are those two triangles congruent? No, definitely not the same. Now, in order for us to check similar, we have to check the scale factor. So, everybody on your own, go and count these. We need to check the scale factor. Don't worry about the diagonal side of your triangle. You're just looking at your length and your width and your height. I think the top one is 3 and 6. Am I right? And the bottom one is 1 and 2. Okay, now we got to set up our fractions. 6 would match up with 2. 3 would match up with 1. What's 6 divided by 2? 3. What's 3 divided by 1? 3. Are those two triangles similar? Yes. Yes. Okay? I think there's some problems today that you have to drag the slider to get the shapes to match up. Don't forget to actually do that. You will not have any work to turn into me. When you're done, do not talk. Find something else to work on.